So good day and welcome to this lecture, to this video lecture on Chem 2223 Lab, which is all about obtaining representative samples. So I am your instructor for the first half of this subject, John Edward Executor. So I hope you have your attention spans with you because I am currently sick at the moment and will have a slower lecture than usual. So to start off, so we will have an overview. So the first one, chemical analysis uses only a small fraction of the available sample. So importante na meron ka lang small fraction na ginagamit sa available sample mo kasi it's possible na mag-fail yung analysis mo. Hindi mo makuha yung desired uh, desired result. So, possible na mag-uulit-ulit ka ng analysis. So, and then, it's possible din na after halimbawa 6 months, lalo na sa research, so, yung sample na inanalyze mo 6 months prior ay hindi nagko-conform dun sa trend. So, pwedeng i-analyze mo ulit siya just to make sure that the result that you obtain is the real result that does not really conform to the trend. Kasi minsan nakakaduda kapag hindi na conform yung result mo dun sa na-establish mo trend. But it's also possible that it's the result that is meant to be. And then, lastly, so pagka small fraction na yung ginagamit mo ng available sample, so it's possible na mas konti lang yung gagamitin mong reagents for that analysis. So, it's also a cost-saving process. So, pangalawa, knowing how much sample to collect and how to further subdivide the collected sample to obtain a laboratory sample is vital in the analytical process. So, para dito, pwede natin i-take for example yung collect environmental water sample. So, halimbawa sa river, so marami ka na kasing makukuhang properties dito. So, halimbawa is conductivity, pH, and turbidity. So, and then other chemical aspects such as nitrate content, phosphates content, heavy metals, and then biochemical oxygen demand. So dapat alam mo kung bago ka pala mag-collect, alam mo na dapat kung gaano karami yung i-collect mong sample para doon sa mga specific analysis na to and kung paano mo sila i-divide. Kasi meron dito mga sample na kailangan mo nang i-stabilize, kailangan ilagay sa concentration, kailangan lagyan ng concentrated acid para ma-dissolve yung ions. Pero may mga sample din, halimbawa yung for the analysis of biochemical oxygen demand na hindi mo pwedeng lagyan ng acid kasi hindi mo na makakalculate yung biochemical oxygen demand kasi mamamatay yung mga species which are causing the biochemical fixation of your target components. So next one, statistical methods are used to aid in the selection of a representative sample. So pagka nagsiselect ka ng sample, so halimbawa, meron kang 1 dozen of eggs. So pagka ikaw lang mismo ang nagsiselect, so it's possible na meron ka na incorporate na bias. Kahit na akala mo ay completely random yung selection mo ng sample. So it's possible na meron kang bias in terms of the size of the egg. So kung gaano kalinis yung egg, and then its location in the egg tray. So, ang maganda rito ay dapat gumamit ka ng statistical methods, so randomization methods para sigurado ka na walang bias yung pag-select mo ng sample kasi hindi naman alam ng computer yung characteristics ng egg. Parang ang alam lang niya is yung label. So, pang-apat, the analytical sample must be processed in a dependable manner that maintains sample integrity without losing sample or introducing contaminants. So, napakaraming processing methods na nakakaapekto ah, dun sa levels ng iyong analyte. So, let's just take for example yung analysis of antioxidants in vegetables. So, halimbawa, ang sample mo ay eggplant. So, unang cut mo pa lang dyan sa eggplant, pag na-expose yun sa air, so, ma-activate na agad yung kanyang polyphenol oxidase. So, yung polyphenol oxidase, so nagbe-break siya ng iyong polyphenols, which can cause a reduction in your measured antioxidant values. So, kailangan kino-consider yon na hindi mo malulost yung iyong analyte of target analyte, or kung malus mo man yung target analyte mo, dapat naka kailangan aware ka doon sa pagkawala ng analyte para magamit mo siya sa results. So, many laboratories use automated sample handling methods. So, the best example here is your HPLC. So, pagka yung HPLC mo, so, meron ka na sampler, meron ka na automatic sampler which collects the sample from your vial, and then uh, dispenses a specific volume, which is same across the board. So, hindi ka na mag-worry na na mas konti yung sample na ma-dispense mo sa sample 1, sa replicate 2, sa replicate 3, kasi yun nga, as I will discuss later on, so meron kang pagtaas ng error na ma-observe as your analyte concentration decreases and your sample amount decreases. So, ito na yun. So, magsisimula tayo sa sample size. So, meron tayong apat na type of analysis based on sample size. So, you have macro, semi-micro, micro, and ultra-micro. So, yung macro, so siya yung pinakamalalaking sample size, which is greater than 0.1 grams. And then, yung ultramicro has the smallest sample sizes, which is 10 to the negative 4 grams. So, habang lumiliit itong sample size, mas tumataas yung chance na there will be mistakes in handling your sample, and also yung effect ng possible degradation ng analyte ay nagmo-multiply. So, sa analyte level, so meron ka ding several different categories. So, major, minor, trace, and ultra trace. So, sa major, so meron kang 1 to 100%, while sa ultra trace, meron kang less than 1 parts per billion. So, sa ultra trace, so dapat meron ka dito very, very sensitive equipment, and then yung dapat handling mo ng sample mo ay very, very, masyado dapat maingat. Kasi kapag nag-degrade yung analyte mo na ultra trace, so hindi mo na siya matidetect. So, kaya yung mga HPLC system, high performance liquid chromatography, meron na silang oven sa loob. So, or meron na silang cooling system sa loob. So, in case you need your sample uh, to be stable at a certain temperature. So, ito makikita natin sa slide na to, na as you increase the log concentration, as you decrease the log concentration, so tumalaki yung relative standard deviation. So, ito nga yun. So, pagka kasi malaki yung sample size mo, so mas marami kang analyte, so tsaka mas nadadilute yung errors caused by degradation, human errors, and etc. While kapag 1 part per billion lang yung sample mo. So, pag yun nawala, so mag-false negative ka na. Just because hindi hindi kasi nagavalue masyado yung error kapag sobrang liit na ng concentration ng iyong analyte. So, in the real world, so you have real samples. So, analysis of real samples is complicated by the presence of the sample matrix. So, let's just take, for example, the analysis of bacteria using DNA-based biosensors. So, dun sa matrix na yon, so it's possible na meron ka mga nucleases. So, nucleases, ito yung mga magde-degrade ng iyong analyte, ng iyong DNA. So, kapag ka na-degrade na yung DNA mo, so, pag gumamit ka ng DNA-based biosensor, so, possible na hindi na magbabind yung recognition element mo dun sa DNA. And kapag ka naman yan naman ay PCR, so mas common sa inyo, mas recognizable nyo itong PCR dahil sa COVID. So, hindi na mag-multiply ng maayos yung target DNA mo pagka meron kang nucleases. So, pangalawa, so the matrix can contain species with chemical properties similar to the analyte. So, possible na mangyari ito pagka sa precipitating reactions. So, pagka nagpe-precipitate ka, it's possible na merong co-precipitation. So, pagka may na-co-precipitate ka na hindi mo target kasi similar yung properties niya, it could be possible na dadagdag yung mako-form na precipitate sa weight nung makukuha mo. So, this will lead to overestimation or a false positive if it's just a determination. So, if the interferences are caused by extraneous species in the matrix, they are called matrix effects. So, again, dun sa example ng PCR, so pagka nag-amplify ka ng DNA or RNA, kapag meron kang extraneous species in the matrix, example nito is inhibitors. So it's possible that they will inhibit the replication process. So hindi nila naapektuhan mismo yung iyong analyte, yung iyong DNA or RNA, but it's possible na naapektuhan nila yung reagents na ginagamit mo to multiply your DNA and RNA. So such effects can be induced not only by the sample itself, but also by the reagent and solvents used to prepare the samples for the determination. So kaya kapag nag-analyze ka ng HPLC, via HPLC, so dapat HPLC water yung gamit mo. Kasi pagka meron ka lang dyan contamination ng mga several ions or different contaminants at unacceptable levels. So it's possible na magbago yung flow rate or yung detection ng iyong analyte. So samples are analyzed but constituents or concentrations are determined. So alam niyo na itong topic na to during your first analytical chemistry laboratory. So the difference of analyze versus determine. So sa sampling, so this is the process by which a representative fraction is acquired from a material of interest. So an example of this is a few liters of water from a polluted lake. So it is often the most difficult aspect of an analysis. So sampling for chemical analysis requires the use of statistics because conclusions will be drawn about a much larger amount of material from the analysis of a small laboratory sample. So kapag ka nagsasample tayo, so syempre hindi naman natin pwedeng kuhanin yung whole material, lalo na kung sobrang laki ng material. So for example, here yung yung polluted lake or yung river or yung ocean. So, hindi mo pwedeng kuhanin yung whole river, whole lake, whole ocean and bring it to your laboratory. So, dapat kumuha ka lang ng representative fraction. So, para makakuha ka ng representative fraction, kailangan mo gumamit ng concept of statistical analysis. So, kasi dito, parang pagka kasi kumukuha ka ng mas small part of the larger sample. So, uh, pwede mong gamitin yung statistics to prove that it really represents your larger population. So, alam niyo naman yung concept ng sample into a population. So, kaya ang sampling ang pinaka most difficult aspect of an analysis kasi dito pa lang it's possible na kahit na sobrang ganda ng method mo, kahit na sobrang sensitive, sobrang selective, kapag sa sampling pa lang mali ka na, ah, wala na, hindi mo na makukuha yung result na gusto mo. So, let's just take for example yung swab testing. So, kapag nag-swab testing ka, so kapag may mali sa sampling mo, for example, yung swab sample mo ay hindi siya na-retain into a cold temperature until mapunta siya sa laboratory and then ma-analyze for COVID through RT-PCR. So, it's possible na mag-degrade yung RNA mo. Kasi yung RNA, so ribonucleic acid, so nag-undergo yan ng autolysis. So yung autolysis, that's the constant degradation of your RNA. So, init yan sa structure niya kasi meron siyang structure motif na nag-allow sa degradation niya over time, which is limited by cold temperatures. So, mahalaga yung step na yun na nasa cold temperature yung sample mo or dapat mabilis yung transportation niya uh, fasa- to the facility which will analyze it. So it is often the most difficult aspect of an analysis. So to obtain your representative sample, so meron ka tinatawag na sampling units or sampling increments. So these are the items chosen for analysis. And then the collection of sampling units or increments is called the gross sample. And then the gross sample is usually reduced in size and homogenized to create the laboratory sample. Paano ba natin ito i-differentiate itong tatlong terms na to? So, going back to our river sampling, so sa river, meron kang different sampling points. So, for example, sa mouth ng river, sa middle ng river, and then dun sa source. So, ito yung possible na maging sampling units or sampling increments mo. So, this will make your sampling a representative of the whole. But it's also possible na ang mag-sample mo lang ay yung nasa mouth ng river bago lumabas ng a bigger body of water. And then, itong mga sample na to sa, let's just make it as the beginning, the middle, and the end. So, pagka pinagsama-sama mo ito, na sample na to, pwede mo na siyang tawagin na gross sample. So, usually, itong gross sample ay representative na siya nung whole system mo. And then, yung gross sample mo, so, dito na kapag ka nag-partitioning ka na, so, ito na yung magiging laboratory sample mo. So, minsan, yung mga samples mo kailangan hino-homogenize din para mas lalong maging representative of the whole. So, for example ito is yung, halimbawa, nagpapalit ka ng vegetables. So, if you have, halimbawa, 10 kilos of eggplant within different markets, so Pwede mo naman siyang pagsamasamahin into a gross sample, pero para ma-sure ka na talagang represented and uniform. Hindi ka din magkakaroon ng bias kasi syempre mas mahirap mag-random sampling kapag ka big solids na yung gamit mo. So pwede mo siyang i-homogenize into a powder. So doon, wala ka na magiging bias sa specific eggplant fruit. So, yun. So the last is the composition of the gross and laboratory sample must closely resemble the average composition of the total mass of material to be analyzed. So ito na ngayon, i-explain ko earlier na pagka meron kang material, possible na hindi pa siya representative of the whole material. Kaya kapag may laboratory sample ka, meron kang additional homogenization steps na nagaganap. So kapag liquid yan, madali yan kasi pag nasama-samahin mo na yung liquid and then hayaan mo lang siyang naturally mag-homogenize. Pero pagka solids, kailangan mo pa ng further processing which usually involves drying and then grinding to a powder or to another homogeneous uh, form. So the composition of the gross and laboratory sample must closely resemble the average composition and total mass of the material to be analyzed. So aside from the earlier explanation na dapat ito ay nag-represent sa material, so dapat kapag nag-homogenize ka, dapat most likely nire-represent pa rin niya yung average composition of the total mass. Kasi yun nga kapag halimbawa meron kang eggplant or another vegetable and then dinry mo siya, hinomogenize mo siya, so it's possible na yung analyte mo ay magbabago din ng concentration. So, baka hindi na siya maging hindi na niya i-resemble yung average composition ng iyong buong system. So, dapat mo i-consider yun. Dapat ko ba siyang i-freeze drying para hindi magbago yung form ng analyte. Kasi di ba kapag nag-freeze ka ng material, so it's possible dyan na-arrest yung chemical reactions kasi at lower temperatures, bumabagal yung conversion. So kapag nag-freeze dry ka, possible na hindi magre-react yung polyphenol oxidase to degrade your antioxidants or convert them into another form. So the laboratory sample consists of a few grams to at most a few hundred grams. So it may constitute as little as 1 part in 10 to the 7 to 10 to the 8 of the bulk material. So yun nga, pagka gumagawa ka ng extraction, so usually that consists of few grams and so to at most a few hundred grams pag yung mga samples po ay yung mga malalaki and uh, pagka sobrang liit ng population no analyte mo. So for example, if you want to detect salmonella contamination in your egg, so pag sobrang konti ng population ng salmonella mo sa egg, so it's possible that you have to use the whole egg. So that may be more than 20 grams to a little more than 50 grams. So to have your representative sample. So there are some goals of the sampling process. So one is obtain a mean analyte concentration that is unbiased estimate of the population mean. Yan. So yan yung pinaka-importante sa pagsasample. Dapat matanggal mo yung mga biases. So obtain a variance in the measured analyte concentration that is unbiased estimate of the population variance. So simple din ito. So tinatranslate ko lang yung possible results ng population into a sample population. Kasi ito nga ay gusto ko nga makapag-derive ng uh, conclusions from a small amount of samples. So for example, the typical in the analysis is 3 samples to represent your to represent a whole population which usually consists of more than 50 samples. So there are 4 sampling methods. So there are 5. So random sampling, systematic sampling, convenient sampling, cluster sampling, and stratified sampling. So these sampling methods may or may not use statistical tools in order to determine your sample. So yung random sampling ay na-explain ko na po kanina dun sa example ng egg. So sa computer, so lalabas ka lang ng random numbers in Microsoft Excel or in Google Sheets, and then pwede mo na magamit yun into random sampling of your system. So for these 5 sampling methods, mag-upload ako ng mga videos regarding this para makita nyo kung paano siya ginagawa. So that ends this lecture, and thank you for listening.